Welcome, everyone. Today we are diving into a foundational topic in Microsoft Azure, creating and configuring storage accounts. Let's get started. Let's begin by defining what an Azure storage account actually is. As noted in our first bullet, it is a cloud-based resource that provides massively scalable and secure storage. For the basics, it gives you a unique, global namespace to access your data via the internet. Why do we use it? Because it consolidates multiple distinct storage needs into one easily managed platform. How do we interact with it? Through standard tools like the Azure portal or command line interfaces. Diving deeper, it's crucial to understand that one storage account acts as an umbrella for 5 core services: blobs for objects, files for network shares, queues for messaging, tables for NoSQL data, and managed disks for virtual machines. Looking at this flowchart, you can see the Azure storage account at the top, acting as the central management container. From there, it branches downward into the 5 core services it provides. We highlight Azure Blobs on the left, which stores unstructured object data like images or backups. Next to it is Azure Files, providing traditional SMB or NFS cloud file shares. Understanding this hierarchy helps you see that when you configure settings on the storage account itself, those settings often cascade down to these underlying services. Moving to slide 2, the first major architectural decision you make is choosing a performance tier. What is a performance tier? It dictates the physical hardware backing your data. As a basic rule, Azure offers 2 options, Standard and Premium. Why does this matter? It is a direct trade-off between cost and performance. You need to align your choice with your application's I/O requirements. How is this configured? You simply select your tier on the Basics tab during creation, but beware, you cannot change this setting after the account is created. In our deep dive, remember that standard storage uses traditional magnetic hard drives and supports all storage services. Premium uses high-speed SSDs for ultra-low latency, but requires you to select specialized account types depending on whether you need premium files or premium blobs. This visual breaks down the performance tier decision. From the starting diamond, we split into Standard and Premium. Following the standard path upward, we see it utilizes magnetic HDDs, resulting in the lowest cost per GB, and seamlessly supports all 5 storage services. Following the premium path downward, we see it relies on solid-state drives. This delivers high I/O and low latency, but points to specialized account types, meaning you must intentionally design your premium architecture based on the specific service, like file shares or block blobs, that you intend to use. On slide 3, we address the storage account type, sometimes referred to as the kind. What is this? It's the classification that determines exactly which features are unlocked for your deployment. The basic best practice is simple: always use General Purpose v2 or GPv2. When would you use something else? You only select specialized types like block blob storage or file storage when you are utilizing the premium performance tier we just discussed. Why is GPv2 the standard? Because it supports all the latest Azure innovations, including lifecycle management and access tiering, giving you the best flexibility. For our deep dive, be aware that you might still encounter legacy general purpose v1 accounts in older environments. While they exist, Microsoft strongly recommends against using them for any new deployments, as they lack modern cost-saving and security features. Here we have a mind map categorizing the account kinds. Branching to the top right is General Purpose v2, highlighting that it is the default choice, supports all services, and supports access tiers. Branching to the bottom right, we have our premium specialty types, specifically block blob storage and file storage. Finally, branching to the left, we identify the legacy types like General Purpose v1, clearly marked as not recommended. This mental map should be your guide anytime you are provisioning new storage resources in Azure. Slide 4 covers a critical resilience topic: data replication and redundancy. What does this do? It automatically copies your data across different physical locations. As a basic overview, Azure offers several levels, from locally redundant storage up to highly complex geozone redundant storage. Why do we need this? It protects your organization against everything from a failed disk drive to a massive natural disaster taking out an entire region. How is it set up? You choose your redundancy level during creation, though Azure does allow you to upgrade certain redundancy types later. Diving deep, let's understand the mechanics. LRS maintains 3 copies of your data within a single data center. ZRS protects against data center failure by spreading copies across 3 separate availability zones. GRS takes it a step further, copying your data hundreds of miles away to a secondary paired Azure region. This diagram visually maps out the redundancy expansion. Starting in the primary region on the left, you can choose LRS, which keeps 3 copies tightly packed in one data center, or ZRS, which spreads them across 3 zones. The dotted lines show how these local strategies can be extended geographically. LRS can be upgraded to GRS, and ZRS can be upgraded to GZRS. Both of these geo-redundant options asynchronously copy your entire dataset over to the secondary paired region on the far right, ensuring survival even if the primary region goes completely offline. Let's optimize our costs on slide 5 by discussing access tiers for blob storage. What are access tiers? They are pricing models optimized for your specific data usage patterns. The basics include 4 tiers: hot, cool, cold, and archive. Why do we use them? Because it's a financial trade-off. The hot tier charges you a premium for storing data, but makes accessing that data very cheap. Conversely, the archive tier is incredibly cheap for storage, but heavily penalizes you financially if you try to read it. When should you use them? Keep active data in hot, transition 30 to 90-day backups into cool or cold, and push long-term compliance data to archive. For our deep dive, you must know that the archive tier is truly offline tape storage. If you need a file from archive, you must rehydrate it to a hot or cool tier first, a process that can take up to 15 agonizing hours. This chart illustrates the cost dynamics of access tiers. At the top, the hot tier holds active data, resulting in high storage costs, but cheap access. In the middle, the cool and cold tiers represent a middle ground for infrequent access. At the bottom, the archive tier offers the lowest possible storage cost for offline compliance data, but carries the highest access cost. Notice the dotted arrow returning from archive to hot. This represents the mandatory rehydration process, highlighting that archive data cannot be read directly. It must be moved back to a warmer tier first. Slide 6 focuses on the actual mechanics of creation and securing the network. What is the process? Azure provides a tabbed wizard guiding you through basics, advanced, networking, and so on. A fundamental rule you must memorize: your storage account name must be globally unique across all of Azure, between 3 and 24 characters, using only lowercase letters and numbers. How do we secure it? During this wizard, the networking tab is critical. Why? Because by default, Azure makes storage accounts accessible from the public internet. You must restrict this to protect your data. For our deep dive into security, the ultimate best practice is to disable public access entirely. Instead, you deploy a private endpoint. This effectively injects a private IP address from your own virtual network directly into the storage account, ensuring traffic never traverses the public internet. This sequence diagram maps out a secure creation workflow. First, the admin inputs the globally unique name and selects the performance tier in the Azure portal. The portal immediately validates if that name is truly unique across the globe. Once validated, the admin instructs the network engine to disable all public access. The admin then creates a private endpoint. Finally, the network engine confirms that the storage account is now fully secured and only accessible from within the organization's private virtual network. This is the gold standard for deployment. On slide 7, we look at configuring data protection. What is this? It's a suite of built-in features to save you when data is accidentally deleted or maliciously overwritten. The basics are found on the Data Protection tab during creation, where you can enable soft delete for blobs, containers, and file shares. When should you use this? Always. It is your primary defense against ransomware and accidental administrator errors. How does it work? You simply toggle the feature on and set a retention period. The default is 7 days, but you can stretch it up to 365 days. In our deep dive, the most robust strategy is combining soft delete with blob versioning. While soft delete protects against deletions, versioning creates a historical snapshot every single time a file is modified. Together, they allow you to achieve true point-in-time restoration for your data. This state diagram illustrates the lifecycle of a file protected by soft delete. We start with an active blob. When a user deletes the file, it doesn't disappear, it transitions into the soft deleted state. It remains in this holding pattern for the configured retention period, let's say 7 days. If the deletion was an error, an admin can intervene and undelete the file, returning it safely to the active state. However, if the 7-day retention period expires without intervention, the file transitions to permanently deleted and the data is gone forever. For our final slide, we tackle storage encryption. What does Azure do? It encrypts all your data at rest using military-grade AES 256-bit encryption. As a basic rule, this is enabled automatically on every storage account, and it physically cannot be disabled. Why? Because it guarantees that Microsoft meets strict global compliance standards like FPS 140 to 2 out of the box. How is it managed? By default, the encryption relies on Microsoft-managed keys, meaning Azure rotates and protects the keys transparently. If your organization has strict compliance rules, you can switch this to customer-managed keys, linking the storage account to your own Azure Key Vault. For our final deep dive, if you are handling ultra-sensitive workloads, you can enable a setting called Infrastructure Encryption during account creation. This provides double encryption, encrypting the data once at the service level and again down at the physical hardware level. Our final flowchart visualizes the encryption pathways. Your data at rest enters the Azure encryption engine. From there, it follows one of two primary key management paths, the default Microsoft managed key, which is completely transparent to you, or the customer managed key, which gives you control by storing the keys inside your own Azure Key Vault. Furthermore, notice the dotted line branching down to infrastructure encryption. If selected during account creation, this ensures a secondary layer of encryption is applied directly at the hardware level, providing ultimate peace of mind.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB730 exam, if you open it, so you can see here this and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.